So, how do we work with vectors? Okay, so we said a vector is something that has got magnitude and direction. So the simplest way to draw a vector is simply with an arrow. So longer arrows mean larger magnitude. The way in which direction in which it points tells me the orientation of the vector. So let's say this is, let's draw an XY axis. Let's think about, for example, Ilias earlier walking to his IOU1 chocolate paper. So we said that let's take Ilias's initial position as our point of reference. So Ilias had to walk this far along X. So let's call that his first displacement. So this I'm now going to draw explicitly as a vector. So let's call this vector just R1 with a little bar. So from there to there gives you the magnitude. The direction of the arrow tells me the direction of the vector. So this is the first displacement. And then Ilias had to stop, and then he had a second displacement, so he changed his position. From there, he went to there. So let's call this vector R2. That's our second displacement. And now we encounter our first problem. What we want to do with vectors is we want to calculate things like what would the total displacement be? So what is the total, sometimes called the resultant? Now, in mathematics, if I ask you, you've got 2 apples, and now I give you 4 apples, and I ask you, what's the total number of apples you've got? You say 6, because in our minds we think, if I've got something, I add to that, and I want to get the total, we must add things together. So if I want to rephrase this question into a mathematical phrase, what I want is basically, I want to figure out what is vector R1 plus vector R2 equals to. So if I want the total displacement, I've got one displacement, then I've got another displacement. What is the total displacement? Now, by definition, displacement is the change in position. So Ilias started over here, he ended up over there. So his total change in position is from the origin to that point. So this is his total change in position. So graphically, this tells me how to add up vectors. So I take the first vector, if it's a displacement, take the second vector, and then from the tail of the first one to the tip of the last one, I draw another vector, and that gives me the total. Right, because it makes sense. Let's say, if we say that vector R had a magnitude equals to 4, and vector 2 had a magnitude equals to 3, so this was 4 meters, this was 3 meters, then the magnitude of the total vector from Pythagoras' theorem is just the square root of 4 squared plus 3 squared. This is just equals to 5 meters or centimeters or whatever. Now you can see clearly, if we added vectors like they were regular numbers, 3 plus 4 is equals to 7. Right? So that, and Ilias didn't end up 7 meters away from where he started. He ended up 5 meters away from where he started. So if we add vectors, we need to take into account that they've got direction. So the rules of addition and subtraction and multiplication for vectors are slightly different than what they are for regular numbers. And if there's anything I want you to remember from today, it's that when you're writing a test, make sure that what you are working with is either a vector or a number. Because if it's a vector, you need to take into account things like directions when you add them together. If it's just two numbers, if I've got 10 kilograms of mass, to that I add 20 kilograms of mass, I will always have 30 kilograms of mass. However, if I walk 4 meters in one direction, 3 meters in another direction, I'm not necessarily always going to end up 7 meters away from where I started. I can end up anywhere between 7 meters away and 1 meter away, depending on the directions of these vectors. So this is basically how we're going to do vector addition. We will do a bit more mathematical, rigorous way a bit later. But let's now look at a different problem. Let's say again x, y. So what we want to figure out, we now know how to add vectors, but how do we subtract vectors? So if we think about displacement, again, it's going to be our guiding example. Let's say we start out over there and we walk a certain, we change our position by this much to end up over there. So just in simple English, forget about the mathematics, how would, yes? Sorry. Because, yeah, it's early in the morning. If I had 2 more cups of coffee, it would have not occurred. Thanks. So let's forget about mathematics first. Let's just logically think this through. If I have something, let's say 4 apples, from that I subtract the same amount of apples. So I subtract 4 apples. So I eat up 4 apples. I've got 0 apples left. Right, so that kind of defines subtraction. If I've got something, if I subtract the same thing, I must end up with 0. So let's think about displacement. If we walk from the origin to that point over there, and if I then turn around and walk all the way back, right, so let's say that's R1 and the vector pointing back is called R2. So would you agree with me that if we want to calculate our total displacement, we started from there, we walked to there, we turned around and we came back. So our total displacement is 0. So would you agree with me that R1 plus R2, so I walked a certain distance, then I had a certain displacement, then I had another displacement, and the total change in position ends up being 0. So this means R1 has to be equals to negative R2. Because if I've got something, if I add to it, so if I've got 4 apples, I add to that negative 4 apples, I must end up with 0 apples. So if I walk in a certain direction and I walk back to where I started from, my total displacement is 0. And this then tells me how to define the negative of a vector. So the negative of a vector, let's say it's a vector A, is just, well, we will call it obviously negative A, but it's just a vector pointing in the opposite direction. But with the same magnitude. Right. So we know how to define the negative of a vector. So lastly, if I ask you now, I'll just give you 2 vectors. I say, this vector is vector A, that vector is vector B, and I want you to calculate what's the sum of vector A, what is vector A minus vector B. So that is a minus. So, well, we can write this as well. It would be the vector A plus the negative of vector b. So if that is vector A, we said to calculate the sum of vector A and B, we would place vector B at that tip. Sorry, vector B points in that direction, over there. We would place vector B at the tip, and then we would connect that, and that vector would be A plus B. But now we want to add to A the negative of B. So we know the negative of B is a vector with the same magnitude pointing in the opposite direction. So the negative of B would actually be that. So we just flip B over. And now A plus negative B is the vector pointing from the tail of A to the tip of negative B. So that vector there would be equals to A minus B. Okay, we'll go through this again tomorrow, I think. That's it for today. Thanks.